For part A of this lab, we are going to use these cutouts to determine the chemical formulas for ionic compounds. And so our cation ions here are +1 potassium, +1 copper, +2 copper, and +3 aluminum. Remember, copper is a metal with variable charge, and so when copper is +1, we need the formula to have a Roman numeral 1, and when copper is +2, the name has a Roman numeral 2. The anion pieces are bromide, nitrate, oxide, and phosphate. So bromine is a halogen. This is a polyatomic anion. This is a 2 negative oxide, and this is a 3 negative polyatomic phosphate. And so to complete the data table, you want to make puzzles that have ions that cancel charge and make accurate ionic compound formulas. So if you look at your data table, you want to figure out all 16 combinations of cations and anions. So for compound 1, and compound 2, and compound 3, and compound 4, just to keep things organized, I would suggest you take the potassium cation and try to build a puzzle with a bromide anion. And you can see that 1 potassium and 1 bromine completes a puzzle. Then you can fill out your data table because you have a puzzle that is complete. And so for this first compound, KBr, what's the cation piece? The first combination we looked at is K positive for the cation and chloride negative for the anion piece. What's the ion charge? +1 here, -1 under the anion column. The ion name, how do you name K? It is potassium. And metal cations are named the same as the element name, but since it has a charge, we'll specify that it's an ion. The name of an anion is the element, but change the ending to IDE, remember? And so go back to your puzzle. The next step is to record the number of ions. Well, there's 1 potassium and 1 bromine. So you can just write 1 and 1. Now, what is the compound formula? Well, it's just what your puzzle pieces show. In the formula, it's neutral. We don't write charges. So it's just KBr element symbols. And the compound name, you just put it together from what you wrote up above. Cation first, anion second. And so that would be potassium chloride. Now if I do one more as an example, I'm going to keep my potassium cation and pair it with a different anion. I've just picked oxide. So if I try to put the puzzle together, I can see that I need another potassium cation to complete the puzzle with the oxide. So now that I have a completed puzzle, I'm going to do the data for compound 2. The cation piece is still that light green potassium with a positive charge. Now the anion piece is oxygen with a 2 negative charge, the yellow piece. The ion charge for the cation is +1, for the anion is -2. The ion name, well, the metal potassium is still potassium, and the non-metal oxygen, we change the ending to IDE, so that's oxide. The next step is the number of ions required. How many puzzle pieces did we use? Well, we used 2 potassium ions with 1 oxide ion. So the potassium number required is 2, and the oxide number required is 1. And so to do the compound formula, you write the element symbol and the subscripts for how many. And there's 2 potassiums and 1 oxygen, so it's K2O. And then the compound name, just combine the 2 parts up above. Write the cation name first, potassium, and the anion name second, which is oxide. So that's how you do that. Do all the combinations of every positive cation with every negative anion. There are 16 possibilities here. And so I showed you potassium with bromine and potassium with oxide. Next, I would consider doing potassium with nitrate and potassium with phosphate. Then you know all 4 combinations with potassium are done. And then you could take the next cation, copper plus 1, and do your 4 ionic formula combinations with the copper plus 1. So that would be compounds 5 through 8. Then take your next cation, which is copper plus 2, and do those 4 combinations. Figure out how many of each you need to make a neutral compound. You might use 2, you might use 3, you might use 1, just figure it out. And that copper plus 2 would be compounds 9, 10, 11, and 12. And then your aluminum cation with each of the 4 negative anions will give you your final 4 compounds, 13 through 16. The only thing you don't want to do is mix 3 ions. In other words, if you want to make a puzzle with aluminum in combination with bromine, go ahead and use as many bromines as you think you need to complete the puzzle. That is fine. You do not want to use 3 colors to build a puzzle. In other words, don't do this. Don't use 2 different anions in a compound. Just make 1 cation pair up with 1 type of anion and use however many you need. You have enough pieces to do all 16 combinations. So be careful with charges. Make sure your compound formulas have subscripts. When the time comes, make sure your compound names include Roman numerals for any metals that have variable charge.